Welcome to section 2.2. We're graphing polynomial functions when the degree is higher than 2. So we're not just looking at quadratics, we're looking at polynomials. This intro question I really like, more so because it's getting you without the use of your calculator. And so what we're going to do is look at if we can factor this polynomial. And if you notice, you can take an x out of all of them, but the leading coefficient, that leading number is a negative, so I'm going to pull the negative out as well. So if I take a negative x out, then I'm left with x squared minus 3x minus 10. And I'm going to try and find the zeros so that I can put the zeros on this graph and then kind of graph the general shape of the function. Well, if I look to factor this, negative 10 is negative 5 and a positive 2, so it adds to get negative 3. Therefore, my factored form is negative x, x minus 5, and an x plus 2, and I set that equal to 0. Based on the fact that my degree is 3, I should have 3 solutions, and I do. My first solution is x equals 0. My second solution is x equals 5, and my third solution is x equals negative 2. And so what we're going to do is plot these zeros onto our graph. So at 0, at negative 2, and at positive 5. And what I'm going to do without my calculator, in order to be able to graph the general shape of this function here, I'm going to actually make a table. And what I'm going to do is pick values on either side of these 3 points. So negative 2 is my smallest one, so I'm going to go negative 3, negative 2. I need a place between negative 2 and 0, so I'm going to pick negative 1, 0. And I need something between 0 and 5, so I'm just going to pick 3, and it doesn't necessarily matter. What we're trying to do basically is figure out kind of what is the value. Okay, and so I'm going to show you how to do a couple just so we can kind of see the general shape. But at 0, I know I get 0. At negative 2, I get 0, and at 5, I get 0. And the question is, in between these points, am I above the x-axis or below? And so what I did is I took my value and I actually plugged it into this factored form. And so I'll show you one. If x is negative 3, what I do is take this negative 3 and plug it into the negative x, I get 3. And then negative 3 minus 5 and negative 3 plus 2. And so I plug it into each portion of my factored form. So you have 3 times negative 8 times negative 1, which is a positive 24. So what that says is as I look at this, from this direction, my parabola is going to be in the upward direction. And I could do the same thing with negative 1, and I'll do one more kind of to show you. Let's do the 6. So if I let it be 6, I take a negative 6 because it was negative x, and then 6 minus 5, and then 6 plus 2. Well, negative 6 times 1 times 8 is a negative 48. And so right here, you'll notice then at this portion of my graph, I'm going to be going downward. And you could do the same thing for 3 and negative 1. What you end up getting at negative 1 is negative 6, and at 3 you get 30. And I know I could put negative 6 on my graph. Obviously 30 is just like way up here. And so I get this general shape. And what we're trying to get you to see is this can be done without your calculator by factoring, putting zeros, and then finding places between your zeros in order to determine is it going to be above the x-axis or is it going to be below the x-axis. Okay? Start doing this if you can. Get used to not having your calculator. We're going to start talking about the leading coefficient test. We did this in Algebra 2, and it really starts talking about this end behavior. And so I want to go through that one more time with you. So I'm going to slide my page down. Okay. Again, we're describing what happens at the end of our graphs. And you have 2 options. And in these 2 options, I'm really going to make 4 graphs. Okay. So let's take a look. I'm going to make 4 of them. And because we need to know things about the degree of a graph and also the leading coefficient, okay? And what this says, this n is talking about the degree, okay? If the degree of a polynomial is even, so the degree is a 2, 4, 6, 8, anything like that, you're going to look at two possibilities. The first one is when the leading coefficient is positive, okay? The second one is when the leading coefficient is negative. And I'm going to give you kind of a general shape. This is not the only look, but it at least describes an end behavior for you. If the degree is positive on an x squared graph, we know a parabola would open up. And so when you get higher than a squared, you end up getting a shape that kind of looks like a W. And so if the leading coefficient is positive, this graph will basically both open up in both directions. If it's negative, it will open down in both directions. Okay? And so what I want to do is kind of describe this end behavior. And the way we describe what happens at the ends is we say as x approaches negative infinity. So that means as x is getting smaller and smaller and smaller, as I go to the left, you'll notice that my graph, as I kind of trace this function to the left, my graph is going up. And so the way I say that is f of x approaches positive infinity. And every end behavior needs two parts, as x approaches negative infinity and as x approaches a positive infinity. And as x approaches a positive infinity, again, as I trace, as I go to the right, my graph again is going up, so I say f of x goes to positive infinity. And I do a lot of tracing. I think tracing is one of the easiest ways to look at this. If the leading coefficient is negative, you'll notice that our graph opens downward. We're going to again ask two things, as x approaches negative infinity and as x approaches positive infinity. Basically, it's saying as I go to the left and as I go to the right. But this notation is huge. You have to have both of these notations correct for a quiz and a test. So I'm going to trace. As I go to the left on this graph, my graph is going down. So f of x approaches negative infinity. As I go to the right, my graph is also going down, so x approaches negative infinity. So when it's even or odd, or I'm sorry, when it's even, no matter if the coefficient is positive or negative, basically my f of x, my graph is going to go in the same direction. If it's positive, it goes up. If it's negative, it goes down. Okay? The second type we're going to look at is when the degree is odd. So if the degree is odd, you again have to look, is the leading coefficient going to be positive or is the leading coefficient going to be negative? Okay, so we're looking at those two things again. If the leading coefficient is positive, what you're going to get is kind of a squiggly shaped graph, and it's going to go up from left to right. If the leading coefficient is negative, it's going to go down from left to right. And again, the higher the degree, the more squiggled it gets. So let's do end behavior on this one. Again, end behavior takes two portions. As x goes to negative infinity and as x goes to positive infinity. And so as I look at this, let's go with negative infinity first. This really is reading as I go to the left, where is my graph going? My graph is going down, so I say f of x approaches negative infinity. And when I go to the right, as x goes to positive infinity, my graph is going up, so we say f of x goes to positive infinity. Okay, last one. Let me label these again. As x goes to a negative infinity and as x goes to a positive infinity. And again, I think the easiest way to look at this is to trace it. As I go to the left to negative, I go up. So f of x goes to positive infinity. And as I trace my graph to the right, I go down. Therefore, f of x goes to negative infinity. Okay? My suggestion to you is that you learn these four, because if you can look at a polynomial and you can tell me something about the coefficient and the degree, you shouldn't need your graphing calculator in order to be able to tell me the end behavior. Okay, now let me talk about the bottom. If I look, a polynomial that has a degree n will have how many zeros? And the answer is n. We said above the degree was 3, therefore we had 3 zeros. And so that's the same idea. If your degree is 5, I should have 5 zeros. This also includes multiplicities. Okay, and we're going to talk about multiplicities as we go through, and I'll explain more about that. But that includes a multiplicity, something where a 0 happens more than once. And I'm not going to shift this up or I'm going to lose my graph here a second, but if a polynomial degree n, it has at most n minus 1, what we call turning points. And I want to show you what a turning point means. And let me kind of make it a different color so we're not confused. Let's say this was a degree 3 polynomial. And you'll notice it hits the x-axis 3 times. So let's say this is a degree 3. Turning points are what we call minimums and maximums, okay? And relative minimum and maximums means where do you see the high or the low points of the graph, where you can actually find specific points. And you'll notice here is a minimum and here is a maximum. And if the degree is 3 with 3 zeros, I have only 2 turning points, which is that idea of an n minus 1. So you'll always have one less turning point than you do the degree. And if I go to the one above, let me show you an even one. Let's say this has a degree 4. This only has 2 zeros, but I'm going to tell you right now that there are some that are imaginary or multiplicity. But you'll notice how many turning points. I have a maximum here, and a minimum here. There are 3 turning points for my degree 4 polynomial. And so as you look, again, these turning points are those ideas of a max or a min. Turn the page then, let's look at the back side. Let me change my color again. Let me get back to a better color. Taking a look, let's find the 0 algebraically, and then let's talk about, again, what it looks like on a graph. This is very close to what we did in the warm-up or the intro. This I just am hoping we can do with our leading coefficient. Okay, so let's talk about algebraically. Algebraically means with variables. So what I have is negative 10x to the 4th plus 10x squared. And I'm going to always start by finding the zeros. You'll notice they both have a 10 in common. They also both have at least 2 x's. And I never want my leading coefficient to be negative if I'm going to factor. So I'm going to take out a negative 10 and an x squared. If I take out the negative 10 and 2 of the x's, I have an x squared left, minus, and I took this whole thing except for a 1, and I need a negative 1 because negative 10x squared times negative 1 makes 10x squared. And if I factor this one more time because I can, I get an x plus 1 and an x minus 1. And so my zeros here, I get a 0 of 0, but you'll notice it's squared, and that means we have what we call a multiplicity of 2, where it basically happens twice. And I'll tell you how that relates to a graph in just a moment. I also have a 0 of x equals negative 1, and I have a 0 of x equals 1. And so let's make a graph. And again, I'm not looking for accurate at this point, I just want a general shape. But I can tell you this, I know I have zeros at 0, negative 1, and 1. And so I want to look at the general shape. If I look at this, it's an even degree, and my leading coefficient is negative. So my shape will look like this. And if it's going to go through my zeros, what's going to end up happening is it's going to look something like this. Let me get a color that matches. This is where I want to look, because this is where we had our multiplicity, And our multiplicity of 2, you'll notice the 0 looks a little different than if I had it only occurring once. A multiplicity of 2 basically means that it's going to touch my graph, it's going to go to the 0, and then it's going to leave it again. So it counts the 0 when it enters, and then it counts the 0 again when it leaves. And so there's where the 2 zeros occur. And so we're going to get to this idea of a multiplicity. Actually, let's start there. Let's look at this repeated 0. You have two options. Where you have a repeated 0 with a multiplicity of k. So that happens k number of times. And we're going to look at two different options. If k is odd, okay, so if my 0 happens 1, 3, 5, 7, 9 times, anything like that, then my graph crosses, and here's the big word, crosses the x-axis at that 0 of a. So it crosses, if my multiplicity is odd, if it happens 1, 3, 5, 7 times, then my graph will cross. And you'll notice this negative 1, 0 only happened once, and I crossed my 0. And this positive 1 of a 0 only happened once, and it crossed my x-axis. And so that's important when you start graphing these. Again, our goal is without the calculator. So what's the second option? Well, if k is even, then my graph, will touch. Then my graph touches the x-axis at x equals a, but it will not cross. And that's the big thing. And you'll notice that multiplicity of 2, we kind of talked about the fact that it comes in and counts it and leaves. I don't ever cross the x-axis, but I do touch it at that 0 and then leaves again. And so this is a huge idea. From now on, whenever you talk about zeros, you have to also include a multiplicity if it's greater than 1. Okay? This real 0 idea is a definition. I would like you to take that right from your book. And this is on page 143. And I want that filled in then before you come tomorrow, and that will tell me if you watch this or not. But I want that filled in so that you can look at it. And I think it's kind of idea you know, but this will save us a little bit of time. Okay. Let me slide down to the last couple examples. All right, so we're going to try this one more time, and we're going to take this just like we took it with the intro. Can we do this without a calculator is the goal. Okay, well, it's already factored, which is nice. So this is a 0 of x equals 2. Because it's an odd multiplicity, that means it's going to cross the x-axis. I have a 0 here of -9, and because it's an even multiplicity, that means it's going to touch my x-axis. And my final 0 occurs at 5, and it's like there's a 1 there, but this is again an odd multiplicity, which means it's going to cross my x-axis. So let's try and look at, I guess, a general shape first, and then we'll look at where do we go from our zeros. All right, so I have at +2, I have a 0. At +5, I have a 0, and at -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Okay, now we know that at 9 is going to be where we touch. And so I want to talk about my leading coefficient because that should help me tell. My total degree, 3, 4, 5, 6. My total degree is even. Okay? And so I'm looking at this, my total degree is even. Is there a negative in front of any of these? No, therefore my leading coefficient is positive. So I know the general shape will look something like this. Okay, now I don't know exact, but it's going to have 3 turning points to it. And so the way to figure out some exact is, again, to make a table. And we want to look on either side. If -9 is our leftmost, let's go -10 and figure that out. I need something between -9 and 2. I picked 0, but you could pick anything you want, because I know I have zeros at -9 and 2. I need something between 2 and 5, so I chose 3, because at 5 I have a 0, and then something on the other side, I think I chose 6. Okay? Now, what I would do to easily find these values, again, plug it in, it's already in factored form, but what you end up getting, these are huge numbers, and you probably will need a calculator for this stop. We'll normally give you something with lower multiplicities, or less of them, so it's not maybe what you're looking, these huge numbers. But here's the idea. If it's going to be positive, I know this has to go upward on this side, and on this side it has to go upward as well, because remember, the end behavior for a even and positive graph is for it to go positive in both directions. And so that's got to happen. Well, since this touches, it's going to go back up. And then the next time it's going to come down is going to be at my next 0, and this comes down and comes back up. And so you can kind of see the general shape. If you wanted something more specific, let me give you these numbers, and these are crazy, so you're not going to be able to actually graph these accurately. But this is at 25,920, 3,240, -288, and you know what, I didn't find this one, but I do know it's a positive. Okay, so this, again, it's not a nice graphable one, but at least what you can do is tell me the general shape based on zeros and based on what the graph should look like because of our rules for end behavior. Okay, and that's the idea. The last thing they have is what they call the intermediate value theorem. And what it basically says is you can look at a table or a graph and figure out between what two integers is there a 0. And so what I did is I stuck this in my y equals menu, okay? And I'm going to make a table so that we can kind of see between the values that they asked us, between -3 and 3. 1, 2, and 3. Okay, so I looked at these values. Once I plugged this in my y equals, I went to my table and actually figured out some values. Okay, so here's what we find. At -3, you get -35. You get -11, -1, 1, 1, 5, and 19. Okay? Now, I don't see a single 0 on there. There is not a 0 at one of these integers. But the question we're asking in this intermediate value theorem is there a place where you can see that a 0 would exist? And the answer is here. Because you'll notice it goes from a negative to a positive, which means somewhere between these two numbers, I had to cross the x-axis. And so what we're looking for is this idea between what two integers did a 0 occur? And this occurred between -1 and 0, because here is where we switch from a negative to a positive. If I went from a positive to a negative, you could also count that as a 0. But again, this is the idea. If I look at the table between what two integers, was there a 0? Okay, again, I'm going to X this out. Please take a look at your schedules. I want to make sure that you're not doing extra problems that maybe you don't need. But thank you for watching section 2.2. Again, I do expect that you fill in the page 143 stuff above, and then we'll discuss any questions you have in class.